We're talking about arithmetic and geometric sequences, and an arithmetic sequence, which is the first type that we're going to talk about, is one that has a common difference between the terms. So if you look at this first example, number 1, if you look at between each term, you will be increasing the value of the previous term by 3. So your common difference is d equals 3. I'm also asking you for the next 3 terms of the sequence, and I can just continue doing the same thing over and over again by increasing each one of those by 3. And so I will say that will go to a 7, then it'll go to a 10, and then it'll go to a 13. And it'll keep going forever and ever until you eventually stop. And that is what an arithmetic sequence are. Just because it has a pattern to it does not mean that it is arithmetic. This one increases by 2, then increases by 3, and then increases by 4. Yes, there's an obvious pattern to it, but this is not arithmetic. So that's what we would say, that these are not an arithmetic sequence. So then we are going to talk about finding a given term in the sequence. The formula for finding the nth term, which is the number term that you are looking for, is a sub n. That refers to the number that is in the nth spot, is equal to a sub 1, which is the first term of the sequence, plus n minus 1 times d. n referencing the number term that you're looking for, and d is, again, the common difference. We take this formula and we use it by plugging in the information from the sequence, and we'll find whatever term we are looking for in the sequence. So in this first example, we are given 40, 31, 22, 13. That is a arithmetic sequence. You can see that it is decreasing by 9 each time. And since it's going down by 9, you can say it's arithmetic. The directions say to find the 52nd term of the sequence, and I would not want to, extend the sequence all the way out to what is eventually the 52 term. That would take forever. So what I'm going to do is use the formula, a sub 52. Now this is just a label for the 52nd term. It is not going to be calculated at all. Is equal to a1, which in this case is 40, plus n minus 1, which in this case is 52 minus 1, because I'm looking for the 52nd term, times d, which is the common difference, which in this case is negative 9. Now this is a very easy calculation. All we got to do is 40 plus, you calculate it out using order of operations, and this will get you negative 419. And that is the 52nd term of the sequence. Sometimes you are asked for other terms of the sequence. In this case, you're asked for the 37th term. You have to tell that by just looking at what it's telling you to find. It is done the exact same way as the previous section. You just say a sub 37 is equal to the first term times 37 minus 1 times the common difference between those. Later on, we are asking for the explicit formula. Now, the explicit formula is just a formula that only references directly n. It's a very simple formula to use. So the first thing we want to determine is if it is arithmetic or not. And so we're going to look at the difference between all these terms. And in this case, it's going to be by negative 7. It's going down by 7 each time. We want to write a formula to represent the nth term of this. So we start with the formula that we just had. A sub n is equal to a1 plus n minus 1 times d. And I'm going to plug in everything into this formula besides n, because I want to leave n a variable. That way I can plug in whatever n I want. A sub n is equal to a1 in this case is negative 4 plus n minus 1 is still n minus 1 because I don't know what n is, times d, which is negative 7. We're now going to simplify this formula by distributing, and this is going to be a negative 4 minus 7n plus 7, and then combine our like terms will get me an is equal to a negative 7n plus 3. And this is the explicit formula. That's going to be used in summation notation coming up tomorrow. That's everything for arithmetic sequences. Now what we need to do is move on to geometric sequences. Geometric sequence, just like an arithmetic sequence, is got a common thing between it, but this case it's not adding and subtracting by the same number every time. It's going to be multiplied by the same number. This one in this case is being multiplied by a negative 2 each time. We call this a common ratio. R is equal to negative 2. It is also asking me to find the next 3 terms in the sequence, so I'm going to continue the sequence out. Negative 40, then positive 80, and then negative 160. Now you can see here that this is getting large relatively quickly, even with a ratio of negative 2. That's the problem with geometric sequences. They do tend to get large very quickly. There is a formula for finding the nth term. Let me talk about real quick one that has fractions involved, like number 6 here has fractions involved. you can see here that if I multiply negative 2 times a positive 1/3, I would get a negative 2/3, but I'm going to multiply it by negative 2/3, and that'll cause it to change the sign to a positive 2/3. I will then multiply by 1/3 again, and a 1/3 again, and that will get me these numbers respectively. Now we are looking for the next three terms of the sequence, so we'll know that r is equal to a negative 1/3. We are going to then just keep multiplying, and we'll say that's going to become a negative 2 over 81, and so on and so forth, just by multiplying by a negative 1/3. The next section tells you to find whatever term you're looking for a geometric sequence. The formula is similar but different from the arithmetic. It starts off with an, again that's the number in the nth term, is equal to whatever your first number is, a sub 1, times your common ratio raised to the n minus 1 power. So this is the formula to find whatever term of a sequence that you want. We typically stick with smaller number terms because these, again, do get very large very quickly. So on this problem right here, we look for the common difference, which in this case is a positive 2, even though all the numbers are negative. We are multiplying it by 2 every time. We are looking for the 8th term of the sequence, so what we're going to do is plug it into the formula. A sub 8 is equal to a1 is negative 0.5, that's the first term of the sequence, times r, which in this case is 2, because that's the common ratio between the numbers, and it's going to be raised to the 8 minus 1 power. Now, 8 minus 1 came from the n minus 1. Again, a1 times r to the n minus 1 power, 8 minus 1. Now, what we're going to do is calculate out all this stuff. A8 is equal to negative 0.5 times 2 to the 7th. And then we're going to multiply all this out. A sub 8 is equal to a 64, negative 64. Now, 8 is not a very hard number to do, but, because there's not that many of them, but they do tend to get very large very quickly. You can see that this one is being multiplied by 5 every time, which is a still seemingly small number, but being that it's being multiplied by 5 every time and you got to do it 8 times, the common ratio will be 5, and the 8th term is actually negative 312,500. So it gets very, very large, in this case very, 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 very small, very quickly. Again, with the fractions, we would have to do the common ratio is a 1/5, in fact, a negative 1/5. If you're going to do a fraction, sometimes your calculator will spit you out a very ugly answer like 1.28 e negative 5. That is 1.28 times 10 to the negative 5th power, which is 0.0000128, an extremely small number. And that's fine to have that decimal, but it is an approximation. You may want to consider doing a separate sequence, just looking at the bottom numbers and looking at the top numbers, and doing a sequence for each one of those separately. That way you could write out your fraction answer. And the fraction answer for this one would be 1 over 78,125. If you did the sequence with the bottom, which is 1, 5, 25, 125, the 8th term is this 78,125 number, and you can see that the tops are just alternating signs. It starts off with a negative 1, then a positive 1, then a negative 1, then a positive 1, and so on and so forth. And so you can just find out whether it's going to be negative or positive. In this case, it'll end up being a positive 1 after you're all said and done. The next section is the same type of thing. You're just determining if it is arithmetic or geometric. It is going to be geometric that we are looking for on this page. In this case, it's negative 2. We are looking for the 12th term, so you're going to plug it in using 12 as your n instead of the 8 in this case.